SQLite3 step, passing in that statement, equals SQLite row. So in this case, SQLite row is some sentinel value. That means here you got back a row. I can then go ahead and get column number 0 from this statement and store the result in a char star called C. Then I can convert that char star to an NS string using this syntax, which we haven't had to do before. And though the story sounds complicated, it's mostly just copy-paste of typical code when you want to go from NS strings to C strings. And then self.words, add object S. And just intuitively, why did I have to convert the char star to an actual NS string in order to execute line 3 there? Exactly. A char star is not an object. It's literally just a pointer. But the collection classes in Objective-C, namely NS mutable string, NS dictionary, and the like, these expect pointers to actual objects, where an object is a descendant of what class? NS object. So that's what's expected here. So we just have to jump through some hoops. So in short, this is a god-awful mess, frankly. So this is why there exist like abstraction layers like them core data, so that you don't have to deal with this kind of crap, frankly, when writing code. This is a little too low level and messy when really we're just trying to express ourselves in terms of getting data back from a storage device. But it's doable, and it is supported in iOS. Yeah?
Is the second line in the while loop functionally different from something like NS string with format %s?
That would, NS, oh, so the second line here?
Yeah, NS string start.
Yep, that is exactly the same, except what you just described. String with format is what we'd call a convenience method, but it achieves exactly the same result here. Yeah, Zach?
What's the difference between you putting all this in init with libname instead of the view-did-load?
Ah, good question. Why put this stuff in init with libname as opposed to view-did-load? Does anyone want to take a stab at that? Yeah.
If you reload, you don't have to import libviz again.
Exactly. So if you evict the view from memory, which frankly will not happen in this app because there is only one view. Well, actually, I take that back. It could happen if we background the app, or I get a phone call in the midst of it, or a text message. So the view to save memory could be punted from RAM. And so the implication, as Yella has said there, is that if then I then foreground the application again, or I hang up the phone call and I go back to playing this application, well, the view is going to have to be reloaded, which means I'm going to unnecessarily ask the database for those 5 or 6 words again and just do a lot of work unnecessarily. Now, with that said, it's not hard work to do. It's going to be super fast. And so if you are developing a fairly large application and you really do want to conserve as many bytes as possible so that the iOS operating system doesn't say, forget this, you're using way too many megabytes of RAM, I'm just going to terminate you altogether, which is bad for apps and business, well, then you could say, fine, I'm just going to spend CPU cycles to reload this data later so as to save on memory. So it's just that trade-off that we always saw in 50. Good question. Other questions about SQLite? All right, so I'll wave my hand at the remainder of the code since it's quite like what we saw last week for actually rendering a table view. But recall that a table view, this list of strings in the UI, it pretty much boils down to having a data source and a delegate so that the application can send messages to your class to which you need to respond with answers. For instance, you will be asked, how many rows does your data set have? You need to be able to answer that question. And that's what the functions down there do, methods down there do, just like last week. It's pretty much identical. Any questions? All right, so we've promised for a couple weeks now to peel back the layers of memory management, which have admittedly gotten easier with iOS 5. But unfortunately, a lot of the documentation you see online, a lot of the header files that still ship with iOS, a lot of textbooks or just online tutorials still make ample reference to some of the crossed out keywords here, namely release and retain and such. So we started telling the story last week. When you allocate an object, like an NS string or a student object with alloc, what happens in terms of this concept known as reference counting? In other words, how does memory management work in iOS or in languages like Objective-C? Yeah, so you effectively get not so much back, but inside of the object is stored the secret number 1, which means there is one valid need for this object to remain in memory. So just like in C, you still have the notion of a stack, you still have the notion of a heap, and so when you call alloc, you're grabbing a few bytes from the heap, but ideally you don't want to use those bytes in perpetuity because eventually you'll run out of space, right? The heap tends to go down, at least as far as we typically depict it, so stack is going up, 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 heap is going down, down, down. So if you never actually free memory, as by calling free in C, or by calling formally release in Objective-C, heap grows down, 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 stack might grow up, 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 and eventually these two might collide, or you're just going to use more RAM than is available to you. So freeing up your memory is typically a good thing. So in Objective-C, how is this done? Well, when you allocate an object up here, it gets a reference count by default of 1, and that means one person cares about it, so to speak. The problem is, though, that as soon as you the problem is, though, that in certain contexts, the operating system might decrement that count. For instance, when a method returns, or when the pointer to that object effectively goes out of scope so that no one could realistically have access to it anymore, that memory might very well be reclaimed for you. So how is this done? It's done by this mechanism of reference counting, whereby, again, you allocate an object, it gets a reference count of 1. As soon as that object goes out of scope and you no longer have a pointer to it, the reference count goes down to 0. And as soon as that happens, the operating system can say, oh, I can take back these bytes and reuse them later for something else. But this is problematic because in iOS, where you have very much event-driven programming, you have fairly short methods being called, so you can't keep objects around by way of pointers on the stack because methods are going to return pretty quickly. So objects, so to speak, will go out of scope. So if you want to keep some object around, like a student object, for the lifetime of your program, or in Project 2, if you want to keep a high scores model around, or a gameplay model around, an object thereof in memory throughout the whole lifetime of the program, you need to somehow keep that object in the heap. So how do you do this? You effectively +1 the object. So in the past, literally 6+ months ago, you would literally have to plant that stake in the ground yourself. Upon allocating an object, you would typically call retain, which would +1 its reference count further. And there was this other related mechanism called auto release that effectively would +1 it for you and eventually -1 it for you. But in this case, there was also release, so that when you knew your memory, you were done with that memory, you would then yourself manually call release. So this actually isn't hard. Frankly, it's all about symmetry. If you call alloc, or if you call copy, or if you call retain, the rule of thumb for years was you call release. And it's as simple as that. Well, you can tell these stories quite simply, but in reality, dealing with any kind of memory and pointers, as you may recall from this class or 50, is not easy, right? It's very easy to make mistakes. It's very easy to leak memory. It's very easy to accidentally dereference null. So programmers are not as good at computers at managing memory, as seems to be the case over the years. So this stuff was crossed out with iOS 5, so that the compiler and the runtime on iOS actually figures out when to free memory for you, so you can get out of the business of doing so. We programmers still have some control over, though, how memory is managed. So in what context have we seen assign, strong, and weak? In the context of? Yep, and what context specifically in view controllers? In properties. So recall that properties are nice and magical because they allow you to do two things, one of which we never remember. So what are one or two of them? Yeah, Carl. OK, so it allows you to automatically generate setters and getters, thanks to the @synthesize keyword. And what else? OK, good. So dot notation, right? Just the syntactic sugar of dot notation. So we get those two things from actually using properties. But when we generate these getters and setters, we might actually want to influence how they are implemented underneath the hood. So we can specify that the setter actually uses assign, strong, or weak. Well, what does this really mean? Well, when you say assign, literally the setter will just do x gets y. It will literally just do a copy of whatever the instance variable in question is. This is great for things like primitives, ints and floats and doubles and chars, where literally you just want to copy. But pointers always get a little more interesting. So in the case of pointers, you typically want to say strong or weak. If you say strong, strong does a +1. This means I really care about this instance variable, so whatever the pointer actually is. And strong means make sure that even if other parts of my program don't need this pointer anymore, I, whoever's implementing the class, the property in question, do care about it. So make sure that I plant that stake in the ground and +1 it. Weak means, yeah, it'd be nice to have this pointer around, but it's not a huge deal if someone else frees it because it's not owned by me. And so indeed, the rule of thumb is this. If you are going to be using the property to point at some object that you have allocated in code, it should almost always be a strong property, because clearly if you allocated the object, you probably want to keep it around. If by contrast, you are implementing a property that points to an object that someone else allocated in some other class or in interface builder in a nib file, then it's probably fine to make it weak. So in other words, things like IB outlets that allow you to link your code to a nib file, even though the nib is yours, the nib is what's responsible for allocating the text view and the button and all of the UI stuff. So those objects are not owned by you per se, so a weak property suffices. So that rule of thumb should pretty much get you through almost all scenarios.